Is quantum mechanics an incomplete theory? We are going to look at that from the quantum entanglement perspective. There are two avenues to quantum entanglement. One is the physical avenue, which was initiated by Dirac in 1930, and the other is the philosophical avenue, initiated by Einstein in 1935. The vast majority of people are familiar with the philosophical approach, but not with the physical approach. This is all very neatly explained and referenced in Fundamentals of Quantum Entanglement. The physical approach leads directly to the probability amplitude of quantum entanglement and the probability of quantum entanglement. The philosophical approach to quantum entanglement via Bohm's papers in 1950 led to the EPR paradox. EPR introduced the notion that quantum mechanics was incomplete. A sentiment still articulated today by theorists such as Roger Penrose and his followers. It is the philosophical path to quantum entanglement that led to the introduction of hidden variables. However, it should be said that the interferometric derivation of the probability amplitude of quantum entanglement, as described in Fundamentals of Quantum Entanglement, is direct, transparent, and completely devoid of any paradoxes. In other words, it is free of paradoxes. In my opinion, is quantum mechanics incomplete? Well, every theory of nature is incomplete. Quantum mechanics, for instance, does not describe, at least not yet, gravity. General relativity does not describe atomic transitions. It is completely silent, for instance, about the Lamb shift. Even classical theories are incomplete or needs improvement. For instance, the beautiful theory on heat conduction in solids, explained here in this classic by Carthaw and Yeager, had its equation of conduction of heat in a solid sphere corrected in 1979. In fact, that was the very first paper that I wrote. The dispersion theory of prisms, which began in 1704, was only completed in 1982. That's in 1704, the dispersion of multiple prism expanders was treated by Newton, but it was only in 1982, that is 278 years later, that a generalized theory of multiple prisms dispersion was introduced, and only because it was necessary to explain and design laser designs. John Bell, of the Bell theorem, criticized quantum mechanics as not being exact enough for his taste. But today, quantum mechanics, via its interferometric approach, that is the Dirac-Feynman interferometric principle, leads to resolutions in the femtometer regime, and even can go down to the Planck domain, theoretically, of course. Quantum interference is completely indeterministic, completely stochastic. To accuse quantum mechanics of being incomplete because of the EPR argument, well, that was dealt with in the first edition of Quantum Optics for Engineers. To accuse quantum mechanics of being incomplete because of the Schrödinger equation, the collapse of the wave function, and the so-called measurement problem, completely ignores the physics of quantum interference and quantum entanglement, as explained in Fundamentals of Quantum Entanglement. To accuse again and again quantum mechanics of being incomplete without offering solid experimental proof is, to say the least, a dereliction of duty of those theorists making the accusation. The experiment is the ethos of physics. Let me repeat that again. The experiment is the ethos of physics. It is the experiment that has the final judgment on the beauty of a theory. It is the experiment that has the final judgment on the correctness of a theory. In this regard, quantum mechanics passes with flying colors. The same cannot be said, for instance, on theories of everything or final theories. Advocacy of a final theory demonstrates a basic misunderstanding of nature, a basic misunderstanding of the synergy between physical theory and experiment. As our sensors get better and better, mainly because of quantum mechanics, our theories will get better and better. And this race between experiment and theory will continue for as long as the human race continues. With all the information and knowledge that we have today, to single out quantum mechanics as incomplete is either inherently ignorant or philosophically prejudicial.